We'll now be covering password hashing. So, first, what is hashing? Hashing is a form of encryption where you convert a word, a string, a number, whatever, into another form in such a way that if you look at the encrypted form, you can't get the original back. So let me do a simplified example. So let's say that you have a three sets of numbers. Let's say you have 5, 13, and 29. All right. So you have these three numbers and you want to encrypt them. Well, so the way hashing would do it is, this is just a very simplified example. Let's add 5 plus 13 plus 29, and that would equal 47. So this 47 is the hashed value right here. And so if somebody were to input another set of numbers like 2, 4, 6, all right? If you add 2, 4, 6, you'll get 12, and 12 is not equal to 47. So we know that these three sets of numbers are wrong. And if you have the number 47, you can't guess the original three numbers. So 47 can equal 47, or no, 47 can equal 45, 1, and 1 as well. This is hashing. This will also give you 47. So you can't get the original three numbers, and each sets of numbers have not all numbers have the same hash. So you might think to yourself, if multiple values, so if 45, 1, and 1, and 15, 13, and 29 have equal the same hash, if they're both equal to 47, then doesn't that make hashing unsecure, because multiple numbers can equal the same hash? And that is true, except hashing is it's extremely complex. This is just a super simplified version. If, for example, let's say you have a password called password1, if you were to hash this using the most common hashing method, you'll get this value right here, which is very long. And that's because it's a complicated process to get this value. And the number of other values that also equal this hash are very low. And on top of that, it's difficult to reverse find them. Because password1, that's the type of password that it makes sense to type. But another value they might get is like 56, 435, this might also, I'm not saying it does, but it might also be the same hash as this, but this is a nonsensical password. So if a hacker were to get a hash, then it will take them a while to get the original password of password1. They might get values like this, a bunch of numbers, because back here in our 47 example, if a hacker has the hash value of 47, because okay, let me rewind that. So if a hacker were to hack like a database of our usernames and passwords, if we didn't hash it, they'll have all the usernames and passwords. They'll have user1 and then password1. They can just use this to hack into anyone's account. But if it's hashed, then this password1, or let's say that instead of a password, we have our sets of numbers. So if user1 has this password, if we didn't hash it, then a hacker can just easily enter their account. But if was hashed, they'd have the username1 and the number 47, and so they'll have to guess a whole bunch of numbers together. So go 45, 1, 1. They might go 1, 45, 1, or 1, 1, 45. They go 2, 1. There's a whole bunch of numbers. So hashing the password is very useful, and you should use it whenever you want to encrypt sensitive data into a database. So that way, if a hacker were to hack into the database, they won't be able to use the sensitive information because it's been hashed. So back to our form, now that you know about hashing, we want to hash. So the first name, email, all that's like very unimportant. What we need to encrypt is the password. This is like the most important part of it. So in our form handling, we need to hash the password. So we would go, so we would say password is equal to, and to hash it, there's a very easy function that's already built into PHP, and that's called password hash. And we would feed it our post. Oh no, it's already set that sanitize. So you go values, and it is the password is the 0, 1, 2, 3, 4th item right here. Hash. So that will hash the password right here. Now, there's one more thing we can do here, and this is called salting. And so salting basically is another shell on top of hashing, where although hashing is a good method, it's not foolproof, because if a hacker has a powerful PC, he can do what is called brute forcing, where if he has the hash right here, if he has like 47, then he can do 45, 1, 1, 1, 1, 45. He can like run through every set of numbers, and he has a machine that's like powerful enough where it can do it within like, you know, a couple hours or maybe even a couple days, and he will eventually guess the correct password. And this has happened before. So if you want to so there's a way to sort of mitigate this, and that's salting. So basically what salting is we have our password right here. So I'll just copy this, and we take the original password, we concatenate or use the dot operator, and then we add a string to the end. So we add a bunch of symbols is usually what is done. So in normally a set of 32 random symbols. So right here we have, so let's add like 8 random symbols. So let's add 1, 2, 3, 4, 5, 6, 7, 8. So if we echo the password, and then we can push password into the hash. So here, and then we can echo password again. So now, if we create, let's type in capital P password 1 here too, capital P password 1, and we submit. Oh, didn't have the date of birth. All right, try that again. Capital P password 1, capital P password 1, and we submit. Fatal error. Line 25. Oh, okay, I forgot. We need an extra argument in the password hash. So in our password hash, we need to add an extra argument right here. And this is going to be the type of hashing algorithm that we're using. And there are multiple types, but we'll use and this is all caps since these are constants of password default. So this will use the default hashing algorithm. But there are other ones, but it's all right. So now that we have this, if we refresh the page, should add breaks. Silly me. Needs to be in quotations. Here we go. with a dot. Here we go. Okay, so we have the password 1 with the random symbols, and then we have the hashed value of it right here. So now that we have the hashed value of our salted and hashed password, we can then save this password to our database, which will be covering the JSON part of this video. But now that we've salted it, let me show you one last thing where since this is for a create a new account and you're saving this password to the database, when you do the login page, when you're logging in, you want to check to see if the password that the user has entered is the same as the hash. So in this case, I'll change this password to hash right here. So hash. So we have two values, the $hash, which is this value right here, this hash, and then $password, this should be hash too, and the $password, which is this password right here. So now, so imagine that we're now making a login page right here. We have the password already saved to the user's database, and we're calling it as a hash. And we're taking the password from the login page, and we want to make sure that the password is correct. So the built-in function to do this is password verify, and we take in two values, which is password and hash. So with password verify, the first argument needs to be the plain text password. That is just the salted password before hashing. And the second value is the hashed value that's already saved to the database. So we can write password is correct. Now if we refresh, semicolon, right here, so we verified that the password matches the hash, like so. So that is salting and hashing passwords. And this isn't just for passwords. You also, if you're doing like some sort of financial transaction, then you want to also salt and hash credit card information, bank account information, any types of passwords, just any sensitive information where if a hacker were to steal your databases, then you definitely do not want them to steal this piece of information in the database. So things like the user's name and email, date of birth, none of these generally matter, but the password definitely does matter. So you want to salt and hash those.